Hello students, in this video we are going to discuss demodulator. So we we know the AM wave how to generate by using a diode, right? So after generating the AM wave, so at the transmitter we are transmitting through the air medium, and we are receiving at the receiver, right? So I need only original signal. I don't want noise and carrier signal with that. Just I need only original signal, that is our baseband signal, or we can also call that one as message signal. The process of extracting original signal from the modulated signal is called detector or demodulator. Here we are using envelope detector, that is a diode based detector. So usually we have two types of AM detector: envelope detector, square law detector. Okay, so envelope detector is very simple when compared to the square law detector. So here we are discussing the envelope detector, that is a diode based envelope detector. It is work under the linear region, right? We can also call this one a linear diode detector. Envelope detector is also called linear diode detector. So this is another type of detector. It is a square law detector. We can also call that one as non-linear detector. So in this video we are going to discuss envelope detector. It is a diode based detector. We can also call that one as linear diode detector. Okay, so why we have chosen this envelope detector, diode based envelope detector? Because it is very simple to design, and it is used, as it is very simple, it is used in the broadcasting receiver. And here we are using the resistor and capacitor along with the diode. So in order to extract the original signal from the modulated signal. So we will see how we are extracting the original signal from the amplitude modulated signal using diode, resistor, capacitor. Okay. This is your envelope detector, as I said before. So here we are using the diode, okay, and capacitor and resistor. So this is act as a filter. Okay, so here we are giving the input at the positive of the diode. So we are giving input at the positive of the diode, and that is our modulated signal. Then our original signal modifies the carrier signal. We call that one as modifies with respect to the amplitude by keeping frequency and phase constant, is called amplitude modulated signal. That signal we are going to give at the input of our positive of the diode, and we are taking the output, that is our original signal. We call that one as our message signal, right? So we are getting at the output side of low resistance RL. So we are going to measure at the low resistance RL. Here this CRL acts as a filter. So in order to remove high frequency component in our output, so we are using this filter. So how we are getting the uh, original signal by using the diode? We will see the working operation of the diode. Okay, so I will explain this one using the graphical representation of waveform. See, so this is our input side. We are giving at the input side of positive of the diode. This is our amplitude modulated signal, right? So what happens once if you are giving the modulated signal at the input side of the diode? So as we know, so diode is a unidirectional current flow through the diode. It is a unidirectional device, right? So current conducts only at the positive end of during the forward bias. That is, the positive of the battery is connected to the positive of the diode, negative of the battery is connected to the negative of the diode, right? So at that time diode is acts as a forward bias, right? So when the input signal is positive, so what happens? So it is, your diode is forward bias. So once your diode is forward bias, it starts to flow the current. It starts the conduct the current. So it becomes short. So all the current flow through the load resistance RL. So during the positive of the diode, what happens? Capacitor charges completely. Up to what? So it charges up to the positive peak of the signal. So it charges up to positive peak of the signal, right? So here you can understand. So your capacitor charges up to the positive peak of your input signal, right? So during positive half cycle, so your diode conducts, right? So what happens when the input of the signal is decreases? When the input of the signal decreases, the capacitor become reverse, the diode become slowly reverse bias, right? Diode slowly become reverse bias, and capacitor, it becomes open circuit. It becomes open circuit. During forward bias it is short, during reverse bias it become open. So all the voltage drop across this diode, right? So no current flow through this diode. Then what happens across the capacitor? Start to discharge slowly through the load resistance RL. Okay, so you can see here the capacitor charges very quickly. See here capacitor charges very quickly to the positive peak of the signal. So once it meets the positive peak of the signal, when the input signal start to decreases, what happens? Capacitor start to discharge slowly through the load resistance RL, but it takes long time. So this one is very quickly happens charging, but discharging takes long time, right? So for this one, so there is a, it should have to satisfy the condition, all right? So this is the tau. We call this one as a tau delay time, right? We can also call this one as time delay, right? We are calculating by using the source resistance and capacitor. Okay, it should be less than, that delay should be less than 1 divided by fc. This fc, we call this one as a carrier frequency, right? So your 1 divided by fc is called your time, right? Time period of your carrier frequency. So your delay time or time period of your capacitor, resistance and capacitor, I mean, this is, we call this one as a charging time period, should be very very small when compared to your carrier time period. Okay, so during the discharging time period, what happens? Here at the input side, we are taking Rs into C, but here the discharging time we are taking at the low resistance RL, right? This is the difference in the charging time period. We are calculating using the input resistance, and discharging time period is calculated using the low resistance RL, right? That it should have to maintain this condition. So this is your time period of your carrier, right? Your, this is your delay time. So your delay time should be nice between the time carrier time period, and this is your time period of your input signal, message signal, right? It should be time, your time, delay time period should be greater than 1 by fc, but it should be less than your time period of your message signal, right? So in order to get your signal, this is your original signal, right? In order to detect this original signal, right, we call this one as envelope detector. So we this trace we are doing, right, we call this one as a envelope. We call this one as a envelope, right? So if we will measure this envelope across the load resistance RL, right? So here we are not getting negative half cycle. You know very well, during the negative half cycle your diode is off. Only diode conducts only during the positive half wave of your input cycle. It conducts only positive half cycle. There is no negative half cycle in that. So your during the voltage increases up to the peak period, right, your capacitor get charges very quickly. During when the input of your modulated signal goes decreases from this peak period, it is discharging very slow, right? So based on this concept, so we will get the we can able to identify your envelopes. So in this way we can able to extract, or in order to get original signal, so we are using the simple diode based envelope detector. I hope you understand this concept. Thank you.